Find the absolute maximum and absolute minimum values of f of x equals x to the 1/3 times y to the 2/3, subject to x squared plus y squared is less than or equal to 12. So this is a closed disk. We have a disk centered at the origin, and the radius is the square root of 12. And here we have the cube root of x times the cube root of y squared. This is defined for all x and y in R2. So the maximum and minimum values of this function will occur at either critical points inside the disk or on the boundary of the disk. So first we will find the critical numbers inside the disk. So to find the critical numbers, we're looking for points where the gradient of f is either equal to 0, the 0 vector that is, or undefined. So the gradient of f is f sub x, f sub y. F sub x, x to the 1/3, times y to the 2/3. So f sub x, the y to the 2/3 is a constant, and the derivative of x to the 1/3 is 1/3 x to the minus 2/3. So that's going to put 3 times the cube root of x squared in the denominator. And then f sub y is going to leave the cube root of x as constant. And in the denominator, we have to take the derivative with respect to y of y to the 2/3. That's 2/3 y to the minus 1/3. So that's going to put a 2 in the numerator and 3 times the cube root of y in the denominator. So this vector is never equal to the 0 vector, because if you put x or y equal to 0, then this gradient vector will be undefined. So this gradient vector is undefined if x equals 0 or y equals 0. And in these cases, the value of the function is also 0. If x is 0 or y is 0, then our cube root will give us 0 times something. So that means that f of xy is equal to 0 at these points. Okay, so that takes care of the interior of the region. And now, on the boundary of the region, we'll use Lagrange multipliers, which tells us that the maximum and minimum will occur if the gradient of f is parallel to the gradient of g, where g is this function here. The boundary is the actual circle, and that's x squared plus y squared equals 12, and we'll call this function g of xy. So if the gradient of f is parallel to the gradient of g, then we can have a max or a min. And the gradient of f is here, and I'm not going to rewrite all that again. But this one has to be a multiple of the gradient of g. So the gradient of g, let's just calculate that. The gradient of g, simple enough, is 2x comma 2y. G sub x is 2x. G sub y is 2y. So we want this vector here to be a lambda times this vector. So we have 3, looking at each component, the cube root of y squared divided by 3 times the cube root of x squared is equal to 2x lambda. And the second component, 2 times the cube root of x divided by 3 times the cube root of y is equal to 2y lambda. Let's solve both of these equations for lambda and then set those two expressions equal to each other. So in the first case, lambda is equal to, we'll divide by 2x, so that will leave the numerator together, the same, and we'll put the 2x on the bottom, so 2 times 3 is 6, and this is x to the 2/3 times x, which makes x to the 5/3. That's x to the 5/3. And solving this equation for lambda, dividing by 2y, the 2's will cancel, and we'll just get cube root of x in the numerator. And in the denominator, we have 3 times the cube root of y times y, which is y to the 4/3. So cube root of y to the 4th. So these two expressions are both equal to lambda and hence equal to each other. So let's rewrite this equation. Let's cube both sides of this equation. Cube both sides. So we get y squared over 6 cubed times x to the 5th is equal to x over 3 cubed, which is 27, and 6 cubed is 216, but we're not going to need those numbers for right now. And then the cube root of y to the 4th, if we cube that, we get y to the 4th. So let's clear the equation of fractions, multiplying the denominators to the other side. We get 3 cubed times y to the 6th is equal to 6 cubed times x to the 6th. Let's solve for y. First, y to the 6th is equal to 6 cubed x to the 6 over 3 cubed. And this means y to the 6th is equal to, 6 is obviously 2 times 3, so this is 2 cubed times 3 cubed. The 2 cubed cancels. The 3 cubed cancels, leaving us with 2 cubed, which is 8. We might want to think of that as 2 cubed later. And then x to the 6th. So now take the 6th root of both sides. There are 2 6th roots, so y is plus or minus. The 6th root of 8 is the 6th root of 2 cubed. That's the same as 2 to the 3/6, or 2 to the 1/2, or the square root of 2. And then x, 6th root of x to the 6th, being plus or minus x. So y is equal to plus or minus the square root of 2 times x. And keep in mind that the point xy satisfies the equation x squared plus y squared equals 12. So if I substitute this expression in for y, then the corresponding point on the circle is x squared, solves the equation x squared plus, and then y squared, the plus or minus will just become plus when squaring. Square root of 2 gives us 2, and then x squared. We're substituting this in there, so we're squaring it, and that's equal to 12. 3x squared is equal to 12. X squared is equal to 4. X is plus or minus 2. And if x is plus or minus 2, and y is plus or minus the square root of 2 times x, then we can have the square root of 2 times 2, the square root of 2 times negative 2, negative square root of 2 times 2, and negative square root of 2 times negative 2. And altogether, that will give us 4 points. X can be either plus or minus 2, and y will be either plus or minus 2 times the square root of 2. So we want to check f at these points. So f of 2 comma 2 root 2, for example. So we need the cube root of x, that's the cube root of 2. And then we need the cube root of y squared. Well, the y is 2 root 2, which is the same as the square root of 8. If we square that, we get 8, and then take the cube root, and we get 2. So we had 2 times the cube root of 2. And if we plug in both negatives, we'll get the exact same output, because a negative times a negative here would be a positive. Actually, we always square the y. So this one's always positive. So if whether we plug in the plus or minus here, it's going to be the same thing. We're always going to get 2. And whether we plug in when we plug in plus or minus 2 here, we will get plus or minus the cube root of 2. So what we're saying here then is that f of negative 2 comma 2 root 2, that will equal negative 2 times the cube root of 2. And in both of these I plugged in the positive, but whether it's positive or negative, as I said a moment ago, that's going to be the same. So these 4 points, when you plug them in, you get 2 different outputs. One of them is positive, one of them is negative. And remember, where the gradient was undefined, the function was equal to 0. So these are neither max nor min. And the max is the positive value here of 2 times the cube root of 2, and the min is the negative value, negative 2 times the cube root of 2. So the maximum, the absolute maximum and absolute minimum values of this function on this disk are 2 times the cube root of 2 and negative 2 times the cube root of 2 at the points for the max 2 comma plus or minus 2 root 2, and the min, the points are negative 2 comma plus or minus 2 root 2.